Thank you. Good morning. Yeah, as the speakers before me, I would really like to express my gratitude for being invited here, and I'm especially excited to be able to present on some of the Italian data, a lot of it from sites that we've heard a lot about in the last few days already. So I'll be talking on behalf of myself and Claudio Cavazzuti, who I'll defer to later on if there are any specific archaeological questions. But I also really need to acknowledge all the collaborators and co-authors that put in a lot of effort to gather this pretty big data set. Some of you are also in the audience. And last but not least, also the wet lab and bioinformatics team at the Reich Lab, who do all the really hard work to actually produce the data that I'm interpreting here. So I'll start off with a little bit of what we actually know about the genetic landscape of the third millennium in Italy. And this mostly comes from 4 papers that have been published in the last few years. And because we're talking about bell beakers, one of the important characteristics that we're looking at is the spread of steppe ancestry that is linked to the corded-ware and bell beakers in Europe. So what we know from Italy, we have a few rather securely dated cases of the first appearances of steppe ancestry, and the earliest we have is in Sicily, where we have 2 cave sites, Snello and Buffa, which are dated to around like 2400, 2300, and these are cave sites with a rather unclear context. For example, in Buffa, we do find bell beaker material, but we don't know if it's directly associated with the human material that was sampled. So then we have published from Olalde's paper, the site Parma Rossi, where we have individuals both without steppe ancestry, but also this directly dated individual with steppe ancestry dating to around 22,000, although I have heard that this date might not be correct and it actually should be redated to earlier. And then for central Italy, we don't have anything really from the third millennium, but we have samples from later on, so we can say that by 1600, steppe ancestry has reached central Italy. And in the meantime, on Sardinia, not much is happening. This population pretty much remains genetically farmer-like for a much longer time. So for what I'm going to present here, we have almost 200 samples, and we chose to focus on 3 central regions that are most important and have some interesting aspects, and that is northern Italy, specifically the Po Plain region, then the central Adriatic region centering around Marche, and then southern Italy, specifically centering around Campania, where we have quite a dense data set, but we're also including some sites outside of Campania for comparison. And when I'm going through the data in the next few slides, I kind of, I will talk about 4 generalized phases in which I put all the samples. It's quite simplified, but we'll talk about pre-bell beaker copper age around 4000 to 2500, then samples from around 25 to 21, which are relatively secure from bell beaker context sites, but also contemporaneous late copper age sites where we don't have such a bell beaker context. And then following from 22 to around 16 early Bronze Age individuals. So I'll start with northern Italy. We have 83 sampled individuals, and we have 23 radiocarbon dates. So this is the radiocarbon sequence. Of specific interest would be one individual from Cava Quaresima. This is unfortunately not an individual where we actually have data from, but it gives us an idea about how old the site is. So around 25th, 24th century BC. And I also have the privilege to go over some of the genetic methodologies and concepts, so the later speakers won't have to do that so much in depth. But one way to visualize the genetic data is on the so-called principal component analysis plot, which is basically a way to show genetic distance or proximity of individuals. So every dot or every symbol here is one individual. And the closer they are in the plot, the closer we can say that they are genetically, and this is based on a data set of around 1.2 million positions on the genome that are specifically informative about ancestry. So the gray dots in the background represent modern day Western Eurasian individuals. To the right, we have Near Eastern individuals. This cluster to the left would represent modern day European individuals, and what bridges them in the middle is Mediterranean populations, so modern day Italian populations, for example. And then on top of that, I've plotted some already published ancient individuals to kind of orient us here. So this shaded area represents where we would find Neolithic Anatolian farmers that represent the ancestry of the early European farmers as well. Then up here we have early Middle Bronze Age steppe pastoralists, for example, the Yamnaya culture, which represent the kind of steppe-related ancestry that we see coming in with the corded ware. And then I'm also showing here in the light yellow the kind of more extensive cloud of bell-beaker complex associated individuals from Central Europe, and they fall kind of in between the steppe and the Neolithic or Copper Age, because genetically they're also admixed between these populations. And then for Italy, I plotted some ancient individuals, so the Epipaleolithic and Mesolithic individuals fall quite outside the range of modern day individuals, but they kind of explain what happens during the Neolithic and Copper Age, where there is a shift away from Anatolian Neolithic more towards Mesolithic individuals, because there's a resurgence and an admixture with local Mesolithics, while the early farmers spread across Europe. So this is what explains, for example, why Sardinian Neolithic and Bronze Age individuals plot a little bit closer to Mesolithic. And then for Sicilian Neolithic, we see the same. There's a little bit more shift towards the Mesolithic. And for Sicilian early Bronze Age individuals, there we see for the first time that there's this shift towards steppe ancestry, even one kind of outlying individual that falls within the range of bell beakers. Okay, now that we have that as a background, what happens in northern Italy? Yes. So we have all our pre-bell beaker complex Copper Age individuals falling down here, quite expected within the cluster of Copper Age farmers, also seen in Sicily or Sardinia. Then we have two sites that are actually bell beaker associated, and these individuals are the dark red triangles, and we see most of them fall in the wide range of Central European bell beakers. So there's quite a large diversity of steppe ancestry within these individuals from these two sites. And then there are two individuals, actually, one must be hidden behind the other symbols, but that falls still as bell beaker associated individuals within the cluster of Copper Age farmers. Something similar is seen with the contemporaneous late Copper Age, but not bell beaker individuals. We have some with steppe ancestry, but a large part still plot with the Copper Age individuals from before. And then during the early Bronze Age, we see kind of this decline emerging. So there's a little bit of drop off of high steppe ancestry, but the individuals seem to be like largely admixed between the preceding population and what was the bell beaker Copper Age population, with a large range of steppe ancestry distribution. So for Marke, we have fewer samples, 26, and also fewer dates. And the dates quite well represent the gap that we have. So we have very early Copper Age samples, and then we have a large gap, and then we have some Bronze Age individuals. And this is what it looks like on our PCA. Again, Copper Age in the very expected position. And then we have kind of two groups that also split up by site. We have one site that shows, or one group that has a rather lower amount of step ancestry, but has step ancestry. And then we have the other group that remains more similar to the preceding Copper Age. And then finally for Campania, we have 84 individuals. Also going over all phases, but we don't have bell beakers from this region. We have one individual from Acerra, which falls into the phase of bell beakers and has the site has a pseudo bell beaker pottery, so most likely falls into the later phase of bell beaker. And what you might note, so the date range is quite dense, but you might notice the gap here, and this gap might be related to the repeating volcanic activity in Campania, still ongoing, where the gap covers exactly the time where we have these 7 major Astroni eruptions at the end of the Copper Age. And yes, in the PCA, again, the Copper Age looks like all the other regions before. We have this one individual from Acerra, which has step ancestry at the onset of the early Bronze Age. And then we have most of the individuals of the early Bronze Age falling into a rather tight homogeneous cluster with step ancestry. But the earliest dated individual from the early Bronze Age actually still falls with Copper Age individuals. So there is still maybe some diversity in the populations there. Here I'm showing color-coded the different Y chromosomal haplogroups. So for the Copper Age period, we see all these typical farmer haplogroups, G2, I2, J. What's quite interesting is that in Campania and southern Italy, we also have an R1b type, which might seem a bit confusing because usually we hear about that coming in with the bell beaker, but this is actually a more archaic R1b that is already seen much earlier in Italy. It's, for example, common among the Sardinian farmers already. And so here we see that it's also quite common in Campania and southern Italy. Then in the bell beaker phase, we have the first typical step R1bs coming in. And these are with bell beaker associated individuals, as well as one other site where we don't know the context so well, but all these individuals have step ancestry, and they have this typical, this type of R1b called L2, which I have on good authority, is most common in Bohemia, Moravia, central Germany. So it's a more central Eastern European bell beaker type, which already might be a smoking gun of like the origin of where these bell beaker individuals come from. And what we also see is that, because we have the densest sampling for this time period in northern Italy, but we also see that there is a persistence of individuals without this R1b subtype and without the step ancestry. And then in the early Bronze Age, we have a diversification of R1b lineage. We also have a kind of discontinuation of individuals without any step ancestry at the beginning of the early Bronze Age. So we see beyond these R1b typical bell beaker lineages like P312 or L2, we see also other sublineages coming in that that might represent later mobility into the region. And what's also quite interesting to point out, still on the same data, the PC2, showing the amount of steppe ancestry, is kind of the range of diversity we see within sites. So, of course, among the Copper Age individuals, it's rather homogeneous. And then we see this explosion of diversity within bell beaker sites at the end of the Copper Age. And in northern Italy, this kind of persists within, still in the early Bronze Age, which might point to kind of a continuation of contact with populations that have high steppe ancestry, that have low steppe ancestry. So there might be some genetic pockets that are in contact with each other. Or this might represent chain migration, as explained before by Ian. And this is not something we see in Campania, for example, where it's much more homogeneous. This looks more like a homogeneous population that emerges already formed. And now I'm going to go specifically into the two bell beaker sites that we have. So Via Guido-Rossi is already published in the Olalde paper, and then we have new data from Cava-Quaresima. So I'll start with that. This was, I think, already gone over in Franco's talk, where we have from the individuals that we sampled, only one of them has a bell beaker in their grave. This is a male from tomb 9, and surprisingly, this male has no steppe ancestry. Here's just an overview of the general data we have from the 7 individuals from the site. So this is the male. He has a farming type haplogroup, has no relatives within the site as far as we know from the 7 individuals, and no steppe ancestry. On the other hand, we have one individual up here, which is, for now, with the data set that exists, the individual in late 3rd millennium Italy with the highest amount of steppe ancestry. And then this is again a male. This is here. This male carries this R1b-L2 subgroup, so the one that's frequent in Central and Eastern Europe. Has a lot of steppe ancestry and is also related to other individuals within the same site, and in fact centrally related. So the most closely related to 3 other individuals who might in turn be related to each other, but more distantly. And then we see that other individuals also carry the same R1b-L2. So this kind of means that this individual seems to be socially quite central in the site. However, the grave is not remarkable. There are no grave goods, so we can't really say much more about the context here. We do know something about mobility at the site. So these are strontium isotope measurements, where we see that in general, it's rather moving in the local baseline, with maybe adult males showing a little bit more range, with one exception here, an adult female that is absolutely outside of the range, the local range, with much more radiogenic measurements that would be consistent with maybe the broader alpine region. Unfortunately for this female 33, we have no genetic data yet. There's also no direct date, but she's found within this characteristic ring ditches, and the neighboring grave is also in one of these ring ditches, and this is the directly dated one. This is the ring ditch from the excavation. And now I'm going to show some selected archaeological correlates where we find similar archaeological features in other regions among bell beaker burial sites. So we also find ring ditches, for example, in Czechia. Here I'm showing cremations also among bell beaker sites, which we find, for example, also in Hungary, with this site that has ring ditches as well, cremations. Here another cremation from Czechia. Yes, and that's already that for that site. And now for Via Guido Rossi, this is already published, so it's not any new surprising data, but we have this triple grave here, where we have data from two individuals, these two here, individual A and B, one male and one female, where we see that, and with some bell beaker inventory, we see that within the same grave, we have individuals that are genetically quite distinct. One more typically bell beaker genetically, and one more typically Copper Age farming leg. And they are buried in this house tomb, for which we also have some archaeological correlates, for example, in Bohemia or in Austria. And this is the other individual, a male with step ancestry as well, from tomb 2, where we also see similar pottery, for example, in Hungary. So it was already mentioned that IBD will be super informative. So what is IBD? That stands for Identity by Descent. And with that, we can look at long-range relatedness, so more distant relatedness. With our typical methods that we use, we usually only can say like 1st to 3rd degree related, so very closely, families. But now we can look at maybe up to 10 to 15 degrees of relatedness. And that gives us information on wider networks. So IBD describes identical segments of DNA that are shared between two individuals because they derive from a common ancestor. And the length of this IBD segment, as well as the number of IBD segments that are shared between individuals, inform about how closely these individuals are related to each other, because each generation recombination happens, and these segments get broken up into smaller and smaller pieces until we can't detect them anymore. And this is the same principle that is used, for example, by 23andMe, when they kind of detect your relatives. So this is actually from my own 23andMe report with some random person I've never heard of, who apparently is my 3rd cousin. And 3rd cousin means that we share 2nd great grandparents. So 4 generations back from me to my great grandparents and 4 generations back from my 3rd cousin. So that would be in total an 8th degree relative of mine. So that's something that we can see in ancient data now as well. It doesn't have to be cousins. 8th degree could also mean that somebody would be like an 8th degree ancestor of mine, so actually several hundred years back. And I think in future we'll also be able to tell apart if somebody is like separated through 2 lineages as a cousin or is a direct ancestor. We're not quite there yet. So this is how I'm visualizing it now for the Italian data. So I used all individuals that had good enough quality to do this type of analysis, grouped them by region and by phase. And then you see here the number of individuals that go into every group. So the number of pairs that you can make up between individuals of each group, of course, depends heavily on how many individuals we even have. And then I display as a color code in this heat map the fraction of relatives that we find within these 2 groups from the X and the Y axis. So the more yellow, the higher the fraction of actual relatives we see between these 2 groups. So the upper panel represents up to 8th degree relatives. Most of them, I would say, are like 6th to 8th degree relatives. And then the lower panel is more distant, 8th to 12th degree. This is stochastic, so there's some messiness in the data. So first of all, what we can say is that among the more closely related individuals or pairs, we see that the close relatedness exists if you compare one group with itself. So the most closely related is within the group, which is maybe not surprising. But when we look specifically now, what we're particularly interested in is the bell beaker context group from northern Italy. Where do we see the closest relatives? Well, there what pops up is pretty much the other bell beaker associated groups from Western Europe, from Central Europe, from Central Eastern Europe. So you can really tell that the bell beakers are most related amongst each other and quite closely. We have individuals that, or pairs that are maybe 5th to 6th even related to each other. This becomes more messy when we look at the more distantly related pairs, where we also then incorporate other non-bell beaker copper age, for example, corded ware groups as well that seem to be related, but it just kind of speaks to maybe a larger bell beaker network that emerges then. What we also, for example, what I would like to point out, we don't have so many samples, but for Marke, for example, or Campania, we don't actually see this close relatedness at all. And here are just plotted some actual pairs that we found between the sites. And yeah, you can see clearly in which direction they point. So this is from Cava Quaresima, the up to 8th degree relatives. And we see connections to Hungary, to southern Germany, and to eastern France. And this expands a bit when we look at the more distantly related 8 to 12 degrees, but still mostly points towards kind of Central Eastern Europe. And the same for Via Guido Rossi. We have, I think, Poland, Czechia represented here. And this expands a bit when we look at the more distantly related individuals, where here we actually see some connections more towards the west as well. But which could just mean that they're both descendant from like this wider bell beaker network. I'm also looking at IBD between sites. Okay, have to hurry up a bit. So we see the closest connection, of course, within closely geographically situated sites. We even have in the Copper Age one pair of first cousins from 2 different sites. We also see between phases a lot of connections, which could, especially in northern Italy, which says something about the maybe genetic continuity over time. And we also see continental connections. What we can say is that Marke does not seem to be involved in this. At least we can't detect any connections yet, but that might actually be a case for the connections actually reaching across the Adriatic instead, rather than being involved in this continental network or peninsular network. I think I might have to skip this. This is also a bit hard to explain. But I'll just then jump to the conclusions. So we see steppe ancestry now not directly dated with the new samples we have, but we have can make a pretty good case that we see steppe ancestry in the Po Plain by around 2500 and after 2400 maybe in southern Italy. Then we see that the bell beaker ascribed individuals that have no steppe ancestry and have the farmer typical Y chromosome still appear in the bell beaker sites, and there's this great genetic diversity within the sites and even within burials. Both the Y chromosomal haplogroups, the R1b type, as well as the close IBD connections that we see point to the possible origin of the Italian bell beaker more towards Central and Eastern Europe, while the more distant relatedness that we see reflects the connectivity within a wider network. Then we see trend toward more regional connectivity in the Copper Age, an increase in trans-regional connections with the arrival of the bell beaker complex. We see a continuation of large genetic variability in the early Bronze Age, specifically in northern Italy, which would be a case maybe that there are open corridors that still exist across the Alps, for example, or persistence of genetically more distinct and homogeneous genetic pockets. On the other hand, in Campania, we see that the early Bronze Age population is genetically more homogeneous. And that could be possibly due to this population emerging as a resettlement after these major late Copper Age, early Bronze Age volcanic eruptions. And I skipped the last point, but thank you very much for your attention.